At this point, these problems are becoming repetitive, I hope. The reason we're doing a bunch of them is we want our curve to look good. But now I'm doing 60 milliliters of NaOH. So again, first I'm going to do it the easy way, then I'm going to do an ice table. I need 0.0600 liters times 0.50 moles per liter. Or in other words, I'm going to have 0.030 moles of NaOH. And again, I know from originally, from every problem with 100 milliliters of 0.5 molar, I have 0.050 moles of HNO2. So setting up my Henderson-Hasselbalch equation, pH equals pKa. I'm going to stop writing the negative log every single time. You guys can do that. Take the pKa, the negative log of him, plus the log of the constant or the conjugate base, which the conjugate base is going to be equal to whatever amount of NaOH I added up until equivalence. And we'll get past equivalence because every bit of the OH is going to react and it's all going to turn into water and the conjugate base. So all of it is going to turn into that. Well, if I create that much of the conjugate base, I must have lost that much of the nitric acid, so his value is going to be 0.020. Notice this is the first time in our equation that we have more of the conjugate base than the conjugate acid. So when I solve this, the pH for F turns out to be 3.53, I believe. Now you might wonder, why is it still acidic even though we have more conjugate base? Well, look at the Ka value of the acid. It's 10 to the minus 4, which means Kb of the base has to be somewhere in the ballpark of 10 to the minus 11. So even though there's more base, the base is a weaker base than the acid is an acid. So the acid is still winning out, but the pH is changing. And so now we have another data point, 60 mLs, pH of 3.53. Again, we can do that with our ice table. If we switch over by saying, again, OH ions, should be a negative, plus HNO2 are going to make, kind of a high arrow, but oh well, water and the NO2 ion. Well, we are, from what we calculated back there, I don't remember the value, 0.030 moles of this guy, and just like every other one, 0.05 of him. None of him yet, because again, we're going back and pretending, okay, let's now dump 60 milliliters in all at one time. Every bit of this guy is going to react, so we're going to end up with the following ice table, 0.020 and 0. So I've got, again, values of my acid and values of my conjugate base. I'm ready for my Henderson-Hasselbalch. Again, I've got my acid, which is 0.020, and my base, 0.030. We haven't discussed why it's okay for us to do this in moles in this video. We have in class multiple times. But remember, if I right now, in total, these are in 100 plus 60, 160 milliliters. So if I do divided by 160 milliliters and divided by 160 milliliters, since this is a ratio, they're just going to cancel out with each other. But just like we did in our last one, pH at this point is 3.53.